right, so in this lesson, what we're going to be looking at are zero and negative exponents. All right, so yeah, so the best way, I guess, to introduce this concept or to draw our conclusions is to look at kind of an example here. Okay, so 2 cubed is equal to 8, right? Because that's 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. Okay, so 2 cubed is 8. 2 times 2 is 4. 2 squared is 4. 2 to the first power is just 2. Now you'll notice that from 8 to 4, to get from 8 to 4, I'm dividing by 2, which logically makes sense because I have one less power of 2. And likewise, to go from 4 to 2, I'm again dividing by 2. All right, so if this pattern continued, 2 divided by 2 is equal to 1. That's the first thing you want to realize, is that 2 to the 0 power is equal to 1. All right, now if this pattern continued, right, the next one here, if I take 1 divided by 2, that's 0.5. And then if I did that again, actually, you know what, I'm going to pull out a calculator just to show you. All right, so again, I did 1 divided by 2 equals, that's 0.5. If I take that and divide it by 2, well, that's 0.25. And then if I did it one more time, 0.25 divided by 2, I get 0.125. All right, so these are all true values. Now, when it gets to the negative exponents, is a different color. 0.5 is actually equal to 1/2, right? 0.25, hopefully you realize that 0.25 is a quarter. And 0.125, which may not be all that clear to you, is actually 1/8. Okay, so again, when we divide by 2, we get these fractions. All right. And I want you guys to realize that 1 over 2 is 1 over 2 to the first power. What's about 1 over 4? Well, 4 is a power of 2, right? See up here, 2 squared. This is 1 over 2 squared. And then 1 over 8 is 1 over 3 squared. Sorry, not 3 squared. 1 over 2 cubed. All right. All right, so let's take a look here at these negative exponents. I'm just going to jump straight from 2 to the negative 1. 2 to the negative 1 is the same as, if I jump through here, 1 over 2 to the positive 1. 2 to the negative 2 is equal to 1 over 2 squared. 2 to the negative 3 is equal to 1 over 2 cubed. So hopefully, by looking at just here, you guys can see what negative exponents are. Okay, so negative exponent is 1 over the positive exponent each time, right? 2 to the negative 2 is 1 over 2 to the positive 2. 2 to the negative 3 is 1 over 2 to the positive 3. All right, this will actually continue. So if I was to kind of draw some conclusions from these patterns, I'm actually going to, yes, I did. All right, so the first rule is that the zero exponent rule. Right? So anything, so I just used x as a variable, but any number or any variable to the 0 power is always equal to 1, right? Not 0. So very common mistake is to think x to the 0 or any number to the 0 power is equal to 0. It's not. It's actually equal to 1. As we saw here in this pattern, 2 to the 0 is 1, but this applies for all numbers. Right? Negative exponent rule, which is what we saw here again, is anything to the negative power is 1 over that number to the positive power. Okay, so that's what's written right here. Okay, so for the negative exponent rule, x to the negative a is 1 over x to the positive a. Okay. Cool. So what I'm going to do here, I'm just going to go through a few examples here, just applying these rules. Okay, so for example here, we want to evaluate 4 to the negative 3. It's whenever you're actually asked to evaluate, it's asking you to just find the value of this number. Okay, so 4 to the negative 3. So if I apply the negative exponent rule, this is going to equal 1 over 4 to the positive 3. Okay, which is equal to 1 over 4 times 4 times 4 is equal to 1 over. Okay, so 4 times 4 is 16, times 4 is 64. So 4 to the negative 3 is equal to 1 over 64. All right. And notice as well that this is a positive number. Even though the exponent here is negative, to get rid of the negative exponent, you just write a 1 over. But remember, notice that this thing here is actually just positive. It stays positive. All right. So don't be thrown off by the negative exponent, thinking that the actual number becomes negative. It's actually positive because the base here, 4, is positive. Okay. All right. So let's try another one. But this time it's actually a negative base. All right. So this is going to equal, if I apply the rule again, 1 over negative 3 to the cube. All right. So that's my first step, is to apply the negative exponent, change it to 1 over the positive. So now this is equal to 1 over negative 3 times negative 3 times negative 3. And this is going to equal, all right, so 1 over negative 3 times negative 3 is positive 9, times negative 3 is negative 27. Okay, so 1 over negative 27, which is actually equal to negative 1 over 27. Okay, so this time it's negative because when we multiply the negative 3 by itself 3 times, it is actually turns out to be a negative. Right, so that's negative 1 over 27. Cool. All right, so let's go on to the next example. So this time we want to evaluate 2 to the 0 minus 2 to the negative 2. Okay, so this one here, it's going to actually involve order of operations here. Okay, so we're going to apply BEDMAS. Okay, so according to BEDMAS, we got to take care of the exponents before any subtraction. All right, subtraction is actually last. All right, so first thing I want to do is let's figure out what 2 to the 0 power is. All right, so if you remember, anything to the 0 power is actually equal to 1. So I'm going to have 1 minus. Now 2 to the negative 2, I'm going to switch this to 1 over 2 to the positive 2. All right, so change the negative exponent to 1 over the positive. This is equal to 1 minus 1 over 4. Yes, and now we're dealing with fractions. So I need to get a common denominator. So the 1 I'm going to switch to 4 over 4. 4 over 4 minus 1 over 4, which is equal to, and when it comes to fractions, and you're subtracting them, you leave the denominator the same. All right, so this is going to, the answer here is going to be over 4. And I'm going to take 4 minus 1, which is 3. Okay, so that's the answer there. Okay, so again, applying BEDMAS, I would take care of the exponents first, and then we subtract the two numbers together. Okay. Cool. All right, next one here. So this one here I want to simplify. We have 3 to the negative 3 times 3 to the positive 5 times 3 to the negative 4. Okay, so this one here, we could change this to like 1 over 3 cube, leave the 3 to the 5th up top, and then 1 over 3 to the 4th. Or I think the quicker way to do this is to actually apply the multiplication rule. So if I multiply numbers with the same base, exponents with the same base, this is the same as 3 to the negative 3, and basically what we're going to do here is just add the exponents. So plus 5 minus 4. It just allows us to combine these 3 together. So this is going to equal 3 to the, all right, so negative 3 plus 5 is positive 2. 2 minus 4 is negative 2. So this, when we combine the exponents, it's 3 to the negative 2. Now this I can actually write as 1 over 3 to the positive 2. And 3 squared is equal to 9. So this is 1 over 9. Hopefully that makes sense. All right, so let's go on to the next. This is kind of similar to the previous example, actually, I just realized. All right, so this is going to equal -2, but since we're dividing, we're going to subtract the exponents, right? So this is -5 minus -2. Okay, so this is -2 to the power of -5. Now, if I'm subtracting a negative, these actually change to a positive. Right? So this is actually going to be +2. So as a result, I got -2 to the power of -5 plus 2, which is -3. I didn't give myself that much room, so I'm just going to write it sideways here. This is equal to 1 over -2 cubed. And -2 times -2 times -2 is -8. Right, so this is equal to -1 over. Cool. All right, let's keep going here. The other exponent rule is that whenever you have exponent outside of an exponent, the rule is that we must multiply them together, right? So this is going to be 4. -1 times 2 is -2. So this is going to equal 4 to the -2. So when I have a negative exponent, I'm going to write it as 1 over the positive. That's 1 over 4 squared. It's going to equal 1 over 16. So 4 squared is 16. All right, so kind of, yeah, so these are basically we're looking at negative exponents and applying the exponent rules that we learned in the previous lesson. All right, I believe this last one, yeah. Okay, so this one you'll see is a 1 over 5 to the -2. Now we have a negative exponent in the denominator. So this is going to equal 1 over, and the 5 over -2, I'm just going to write it as 1 over 5 to the +2. Right? Well, if I take the reciprocal of a reciprocal, these actually allow it. Actually, before I do that, explain that. Please forgive me. I'm just going to write this as 1 over 25. Okay, so 1 over 25 is equal to 25. Actually, you know what? I just realized that perhaps. Let me explain why. All right, so 1 over 25. This fraction here, I can actually write it as a division, right? So this is the same as 1 divided by 1 over 25. Well, the rule is whenever you divide by a fraction, same as multiplication and then flipping it. Right? So 1 times 25 over 1. Well, 1 times 25 over 1 is just equal to 25. Okay. Yeah, so that's the answer. Now, the other thing I want to point out, though, here is that whenever you have a negative exponent in the denominator, it's the same as taking it from the denominator and moving it up top. So this is actually equal to 5 and change the exponent to a positive. So this is 5 squared over 1. So 5 squared over 1 is again equal to 25. All right, so whenever you spot a negative exponent in the denominator, you want to actually move it up to the other side, up top, and change it to a positive exponent. All right, so notice here I got 25. I also have 25 there. All right, guys, hopefully that makes sense. Yeah, so that's zero exponents. So I'm just going to scroll back here as a summary. All right, so anything to the 0 power is equal to 1. Any negative exponent is 1 over the positive. And you know what? I'm going to add this part in here. I'm going to add something in here. Get the pen to work. Okay. Or 1 over x to the negative a is equal to x to the a. So this is what we just saw in the last example. Cool. All right, guys. So that's 0 exponents, negative exponents. Ciao.